So the topic diffraction. Diffraction refers to property of a wave to bend or spread when it is passing through a gap or near the edge. And this diffraction depends on two factors. Depends on the wavelength, like these are dotted lines are representing the wavefront. The distance between the two successive wavefront is also called wavelength. So if the wavelength is either greater than or equal to the gap size, then we'll observe a maximum diffraction. But if the wavelength is less than the gap size or the gap is larger, so we have a minimum or small diffraction. So example, if these are the light waves or sound waves and a person is there at point P, so he is able to detect the light if these are the light waves, or if these are the sound waves, the person at position P is able to hear the sound. But another person at position Q, if these are the light waves, because small amount of diffraction is there when it is passing through a larger or a wider gap, so a person is not able to detect these light waves. And if these are the sound waves, then a person is not able to detect the sound because there's a minimum diffraction. So diffraction is refers to spreading of the wave around an obstacle or near the edge, and we have already discussed this part. So the diffraction basically is an apparent bending of a wave when it is passing through the obstacle, or spreading of the wave when it is passing around the gap. So the first one, you can see a gap is much wider, so it is like either no or very small diffraction. The second one, a gap start to reduce, so diffraction is increasing. The third one, the gap size smaller or equal to the wavelength, then we'll observe a maximum diffraction, or wave will spread out in all the direction. But when we compare the intensity, so here, like example, a person, when we compare a person at position 1, another person at position 2, and another person at position 3. So when we compare the intensity of the wave, the person, when less diffraction, more intensity of the wave. Like example, if these are the sound waves, so person at position 1 will be able to hear a loud sound as compared to person at 2, and person at 2 is able to hear a loud sound as compared to person at 3. What is the reason for that? Because small diffraction, like example, if I say there is a 90 joules of energy is transferred, so that 90 joule is divided here 30, 30 and 30. Same thing, what happened? The 90 joule, in this case, when this 90 joule is transferred, so that 90 joule is divided by 5. So example, this is 18 joule, 18, 18. So smaller amount of energy it will receive, 18. The first it was written 30. But here at 3, the same 90 joule is example divided into 10, spread into 10 parts. So when it's divided into 10, so each will only receive how much? Each will receive only 9 joule, because the total is 90, but that 90 is spread out. So at this point we'll receive only 9. Here 90 joule is spread out into example 5 component. So the total each will receive 18. Here the 90 joule is divided into 3, so each will receive 30 joule. So what happened when the wave is spread out more? The intensity of the wave reduce, or intensity of the wave decreases. So this is also a diffraction of the light when it is passing through a gap. As you can see, when the light is passing through the gap, the slit, so there is a spreading of the light as a result, like, and this is double slit. So two slits are there. The black parts are actually representing the slit. So what happened? Two things happen here. One is diffraction. When the wave is passing through the slit, it is spread out from slit 1 and from slit 2. But as these two waves combine on the screen, some region you are able to see bright and some region we have dark. Then we have bright and dark. So what is the reason for this bright and dark pattern? So that is due to interference. And this interference depends on the part difference. Like example, when the part difference is like example 0 lambda, 1 lambda, and other side also 1 lambda, so it will be a constructive. When a part difference is like example n plus half lambda or lambda by 2, like part difference is lambda by 2, 3 by 2 lambda, here also lambda by 2 or 3 by 2 lambda, so there will be a destructive interference. So when the wave is passing through double slit, so two things will happen. Number one is a diffraction, the wave will spread out, and number two is the interference. The diffraction depends on what? Diffraction depends on the wavelength and the gap size. Interference depends on what? Interference depends on the part difference. And if the part difference is like example n lambda constructive, n plus half lambda destructive interference. So Young's double slit experiment is there. As you can see these patterns, maybe you have observed. So these patterns are actually diffraction of the wave. Like this part is a slit. This part is a slit here. This is a slit. So when the wave is passing through the slit, it's spread out. And this spreading of the wave, when it passes through a gap or a slit, what we call that as diffraction. Is it clear, the concept of diffraction? Any doubt till this point? So as you can see, this is a slit and the wave spread out. When it spread out, you can see this is a diffraction pattern. And the Young's experiment, Young's double slit experiment is there, which is about the diffraction and interference. What happened? First, we take a source here. In the beginning, we have a source. That source diffract the wave. And that diffracted wave passes through another slit, but these are like two slits. So that produce more patterns, more waves, diffracted wave. And these two diffracted wave, as a result, what they do, they combine with each other, and their combination depends on the part difference. So when the two waves combine with each other, and at the center part, when they combine with each other, that is known as a central maxima. Maxima means constructive interference. So when we have a constructive interference, what we'll see there will, because it is a light wave, so it will be a bright light, or we call that as a maxima. And we say that region, the central part, n is equals to 1, n is equals to 0, sorry, means that is known as a central maxima, or also known as zero order image. Then the second part, what happened? So basically what is happening, like one wave, two, three, four, and example 5. And same thing, 1, 2, 3, 4, and example 5. So basically what happened, at the center of the screen, the two waves complete the same distance. As the two waves complete the same distance, it means we will have zero part difference. Whenever we have a zero part difference, we'll get a maxima there, or we'll get a constructive, or we'll see or observe a constructive interference, like a bright light. But what happened, the second part, above that and below that, so this is a maxima. Then above maxima and below maxima, what we'll see or what we'll observe, So this is a maxima. Above maxima, there will be minima, and below maxima, there is also a minima, or minimum or minima. Both words are used. So why there is a minima there? Because one wave, like one, two, three, four, an example, five wavelength, and then one, two, three, four, 5, and then 5.5 wavelength. So one is covering 5.5 wavelength, another one is 5 wavelength. So what is the part difference between them, the two waves? So part difference is half lambda. Whenever the part difference is half lambda, it means what kind of interference will be there? There will be a destructive interference, and due to destructive interference, that region will be dark, or I can say we will have a minima. So this is due to the part difference of half wavelength, or we can say 0.5 wavelength. Then again, what happened? And same thing will happen for bottom as well. Example 1, 2, 3, 4, 5. Example 6 wavelength. And 1, 2, 3, 4, 5. And example 5.5. So one is like 6 wavelengths. Another one is 5.5 wavelength. So again, the part difference is half. So below that also, we'll have a half wavelength. So that's why whenever half wavelength, we'll get a minima. So there will be again a dark line, a dark region will be there, or we also call that as a minima. So some regions will have a constructive interference. So we'll observe a bright light, and some region will have a destructive interference. So there will be dark. So example 1, 2, 3, 4, and 5 wavelengths. 5 wavelengths example, and here 1, 2, 3, 4, 5, and 6 wavelengths. So one is 6 wavelength, another one is 5 wavelength. So what is the part difference here at this point? So the part difference is equals to 1 lambda. Whenever a part difference is 1 lambda, what kind of interference will be there? Constructive. So constructive interference, that region will be bright, or we will have a maxima. And same thing, when the waves will reach, so whenever the waves will reach, even at the bottom, 1, 2, 3, 4, 5, and 6 wavelength, and 1, 2, 3, 4, and 5 wavelength. So 6 wavelength and 5 wavelength, the part difference is again 1 wavelength. So it will be a constructive interference. So we'll observe a bright region. So it is alternative pattern of dark and bright regions. So the central is always a maxima. What is the part difference? 0. Then above maxima, there is a minima. What will the part difference? Half wavelength. Then above that, there will be another maxima, part difference 1 wavelength. Above that, there will be a minima. What will the part difference? 1.5 wavelength. Above that, there will be a maxima, part difference will be 2. And same thing, the same pattern is there below as well. So first we have a maxima at the center. At the center always there is a maxima, because the two waves, the part difference is always 0 at the center. Then again it's below, it will be minima, the part difference is half wavelength. Then maxima, the part difference is 1 wavelength. Then minima, the part difference is half wavelength, 1.5 wavelength, sorry. And then maxima, the part difference will be 2 wavelength. So constructive, destructive, constructive, destructive, constructive, and so on. Constructive, destructive, constructive, destructive, and constructive. Is it clear, the concept of the interference and the minima and the maxima produce? So the next session will continue this, the interference, and we will derive a relation like the formulas for this experiment. Any question or a doubt related to the class today?